All right, class, in this notes, we're going to be talking about circular motion. So arc length can be used to analyze circular motion. Suppose an object moves along a circular path S with radius r. So when we are looking at linear speed, it is the rate at which an object moves along a path, and it's called the linear speed. So think of a car on a racetrack, right? That is a linear speed. The rate at which a central angle changing along the path is called an angular speed, and we denote that with this letter called omega, which looks like a W. You can think about a disk rotating in this regard, right? And so we're looking at angular speed. So what are the formulas here? So for a linear speed, we have v is equal to s over t, where s is our arc length, and our angular speed is going to be omega equals theta over t, and theta is representative of our central angle. And in both of these, t represents time. Okay. All right, let's take a look at this example. So recall that each rotation or revolution has a circumference of 2 pi r and a central angle of 2 pi radians. So here we have a bicycle tire that has a radius of 14 inches, rotates at a rate of 125 revolutions per minute. We want to find the linear speed of the tire in inches per minute. Before we get started, it's really important that we acknowledge that our units are all the same. Notice that I want this answer to be in inches per minute, and looks like we are dealing with minutes, and we are in fact dealing with inches. So to start off this problem, we need to figure out the arc length. So from our last section, we saw that the arc length is equal to r theta times our radius r. So in this case, we know that the radius is going to be 14. And our theta, right, in this regard is going to be 2 pi. Now, the one thing we do need to add here is the fact that we are looking at 125 revolutions per minute, which means that this has occurred 125 times. We've done 125 revolutions in the span of 1 minute. So this tells us that our S is going to be equal to 3,500 pi. Okay. So now, in order for us to find our linear speed, we have V is equal to 3,500 pi all over our time, and the time was in 1 minute. So we're going to have 1 minute here. So this is going to equal, if we plug this into our calculator, we're going to get about 10,995.6, and this is going to be inches per minute. Okay. All right, let's look at the next one, number 2. Find the angular speed of the tire in radians per minute. So our angular speed is going to be given to us by omega, and we're going to have theta over t. Okay. But remember that theta is our central angle, and we don't know what theta is yet. So come back over here. So notice that our central angle is 2 pi radians. So we're going to have that 2 pi radians. However, we have been doing this rotation by 125 times, so we're going to have multiply that by 125. So this gives us a total of 250 pi. All right, so then we are going to have, now that we know what our theta is, our angular speed will be 250 pi over 1 minute. So when we plug this into our calculators, we'll get 785.4 radians per minute, or rads per minute. And we should have 2 units, so rad per minute, radians per minute, inches per minute, because this is a speed, so we should have something per minute or per time. All right, take a moment to try number 3 on your own and see what you get. 3 and 4. All right, hopefully you saw that for number 3, we do, for 3 and 4 actually, because we're looking at a CD with a diameter of 120 millimeters, it is really important that we first convert that to a radius. So we have to divide it by 2. So we get the radius is equal to 60 millimeters. And it rotates at a rate of 45 revolutions per minute. So then when we do this calculation, we get 60, which is our radius, times our 2 pi. Because we're doing 45 revolutions per minute, we have that multiplication of 45. For that, for number 3, then we should get 16,964.6 millimeters per minute in terms of that linear speed. For number 4, looking at the angular speed, we first have to calculate our theta, so we get 2 pi equal times 45, which gives us the 90 pi. And so then we get 90 pi, we divide that by our time, and we get 282.7 radians per minute as our angular speed. All right, so for number 5, we have a 16-inch diameter tire on a car is making 500 revolutions per minute. We want to find the linear speed of the tire in miles per hour. So notice that these units are not matching, so we do need to take that into account before we complete the problem. So first and foremost, we want to go ahead and calculate our arc length. So we're going to have our S, and so because we have a 16-inch diameter tire, this tells me that my radius is going to be 8. So I'm going to have 8 times that 2 pi that we, because of it is a full, as we were talking about here, the circumference, so each revolution is going to be that 2 pi, and we're doing this 500 times, so it's going to be times 500. All right, so when we multiply that out, we're going to get 8,000 pi inches. Okay. All right, so now let's calculate our linear speed. So our V is going to be our arc length, which is going to be 8,000 pi inches all over 1 minute. So we are calculating this as per minute. We'll deal with the minute to miles per hour in a second. All right, so when we plug this in to our calculators, we should get 25,132.7 inches per minute. So now we want to be able to give the answer in miles per hour. So let's go ahead and do the conversion now. So because I want to get rid of minute and I really want hours, I'm going to be multiplying by minutes so that my minutes cancel out, and I'll have hours. Next, I want to be able to get rid of my inches and get that to miles. So I know that there are 12 inches. So now my inches are canceled out in 1 foot. But now I want to get rid of feet. So I want to make sure those units cancel out. And so, and I know that there are, oops, I got excited here. I canceled this out too early. Because I want 1 mile, so I do want the mile on top, and I need enough space to write 5,280 feet in 1 foot. So now those feet cancel out. So now with the multiplication, I should end up with the correct units because I have hours on the bottom. Here, let's change colors so you can see it. I have hours on the bottom here, and I have miles on the top, and everything else is canceled out. Okay. All right, so hopefully you see that. So now let's go ahead and do this multiplication, and then we should see that we'd end up with 23.8 miles per hour. All right, let's take a moment and have you try one. Go ahead and try number 6 on your own, and then I'll come back and explain it, but take a moment to attempt it. All right, so for number 6, we saw that we had a circular saw blade with a diameter of 9 inches, which means that our radius is going to be 4.5, and it rotates about 2,800 revolutions per minute. We want to find the angular speed in this point of the blade in radians per second. So remember that with angular speed, we're looking at our central angle over time as our formula. So for our central angle, we're going to end up with 2 pi times the revolutions per minute, which is a 2,800, and all of that is going to be divided by 1 minute. So we end up with 17,592.9 radians per minute. But notice that our goal was to get this in radians per second. So we do need to ensure that we do the conversion here. So we are going to multiply by 1 minute over 60 seconds. And those minutes cancel out. So we do end up with 293.2 radians per second as desired. All right, let's take a look at number 7 here. A windmill has blades that are 14 feet long. If the windmill is rotating at 5 revolutions per second, it's actually really fast, find the linear speed of the tips of the blades in miles per hour. So we're really looking for miles per hour instead of the revolutions per second. All right, so let's go ahead and get started. So when we think of a windmill, I find it helpful to draw a picture. Here is the blade, and I know this looks more like a flower. So from here to here, this is 14 feet long. Right, so I hope you can kind of see that this is actually the radius as it goes along. So let's go ahead and find the arc length here. So it's going to be S. So that radius, that 14 feet long, is our radius, so that's the 14. And so therefore, we're going to multiply that by the 2 pi. And then because we're doing this rotating about 5 revolutions per second, we're going to also multiply that by that 5. So we end up with 140 pi feet. All right, so let's go ahead and calculate that linear speed. So I have V equals 140 pi feet all over 1 second. But I don't want the answer in seconds, nor do I want the answer in feet. I actually want it in miles per hour. So what does this look like? So let's go ahead and start our conversion. So first thing, let's get rid of seconds. So I have 60 seconds in 1 minute. But I also have 60 minutes in 1 hour. So I got my hours down because we can see that these will cancel. My seconds are gone, my minutes are gone, so I'm left with an hour. And so now we want to be able to get rid of feet. So feet, I know that I want to convert that into miles. So there is 1 mile is equivalent to 5,280 feet. So then notice that my feet would then go, and all my units are matching up. So then at the end, I'm going to end up with hours and miles, which is what I wanted. Miles on the top, hours on the bottom. So when we do this calculation, now let's go ahead and plug this into our calculators. We would get approximately 299.9 miles per hour. All right, hopefully that's all making sense. All right, the linear speed v can also be found as follows. So we can see it as our arc over time, arc length over time. We can also see it as r theta over time, right? Because remember, that is our radius times theta is the equation for our arc length there. We can see it sometimes like this, which means that this is the same thing as this, right? Because notice here's that theta over t, and that is our omega. Right? So these are different ways that we can view some of these things, this formula. Let's use angular speed to find linear speed. A ceiling fan has 25-inch blades. It rotates about 40 revolutions per minute. Find the linear speed of the tip blades in feet per second. All right, so I can find the angular speed. Notice that the angular speed is just going to be that 2 pi times the 40. And so I would get 80 pi radians per minute. Now my linear speed then can then be rewritten as r times my angular speed, which is then I take my 25-inch blades, right? That's my radius like we talked in last time, so there's 25. And now let me multiply that by my angular speed, which is that 80 pi, right? Or radians per minute, right? And so then when we do this multiplication, we get 2,000 pi inches over minute. Okay. So now let's go ahead and do that conversion again because we want it in feet per second, not inches per minute. So we're going to start off with that 2,000 pi inches per minute. Let's get rid of the inches. We want to do it per second. So there are 60 seconds in 1 minute. And we want it in feet. So I know that there's 1 foot with 12 inches. Let's go ahead and do these conversions. Make sure all my units cancel out. Oops, I didn't mean to cancel out the wrong one. I got a little cancel happy there. Inches. All right. And so now let's multiply this out. And we should get approximately 8.7 feet per second. All right. Take a moment and try the next one. All right, so for this last one, Ryan is riding a bicycle whose wheels are 28 inches in diameter. So notice that that means that our radius then has to equal 14 because we're going to take half of that. If the wheels rotate at 130 miles per hour, revolutions per minute, find the linear speed in miles per hour. That's where my miles per hour is coming in which he is traveling. So we do need to do some conversions here. So we start off with the angular the angular speed. And so here's our 2 pi. We're multiplying it by that 130 revolutions. So we get 260 pi radians per minute. Now that we have our angular speed, we can find our linear speed. We're just going to multiply it by that radius 14. So we get that 260 times that 14, which gives us a 3,640 pi inches per minute. So now we have to do those conversions. Notice that my minutes here are canceling out. So I can get those hours, and then those inches, I'm going to cancel them out with the feet, which then get canceled out with the miles. So we are left with 10.8 miles per hour as the solution. All right, hopefully that's all coming together.